Another Monday and another milling video for all of you out there. But before I get in on how we're going to machine out this billet L bracket, I'm first going to say, don't forget to like, follow, and subscribe so that you could stay up to date on this. But I'm also going to point out the fact that if you want to see how I design this, and a couple of different techniques I use that might be outside your normal workflow, don't forget to go ahead and go check out the CAD for Cam series when we actually drew this part. So let's go ahead and jump into it. So with our design already open, we're going to go ahead and switch from our design workspace over to our manufacture workspace so that we could start to create our setup. So I'm going to jump to the milling tab to create my first setup. And this is where I need to decide which way do I actually want to machine this part to be able to do it in what I would say is the least amount of setups. But however, how can we efficiently produce this part without any errors and problems? And some of those errors and problems might actually come from cutting these slots. If I'm trying to machine it with a Z axis, let's go ahead and switch our Z so we can picture this all together. Let's say I want to go Z axis up this way, trying to get a tiny 3/16 end mill down in here to cut out these slots might be a little tricky. However, I could use like a tool extension to reach. Same thing would happen is maybe if we do Z this way, we are working with a much larger bore and drilled holes. And if you guys didn't know, you have aircraft drills and things that are much longer, but now I have to machine all the way around the outside of this part and things of that nature. Again, there could be some pluses or minuses on this. However, I think this direction is probably going to be the most beneficial. And then in my personal opinion, I would be putting X-axis the long way here. Again, all my chips are going to come to the front of the machine, make it very easy for me to measure these features based on actually machining this out. So let's go ahead and jump to our stock tab now. We're going to go ahead and go with a fixed size box. Again, because this is very, very hard dimensions at 1.5 inches, we're actually going to round these up pretty dramatically. So let's say the people in the office ordered me some 2x2x2. I'm also offset from the top in my first operation for facing purposes, just so we can clean up that little edge there. As you can see, it's not much to clean up, but again, very, very simple. One thing a lot of you are probably noticing me do here is I'm not actually so much concerned about squaring up my stock. I see a lot of people make that error where they want to square up their stock because it's their first CNC machine. In this world of things, the machine is going to cut very square for us, so we can actually leave it our rough stock size. I'm more concerned personally, first and foremost, to make sure that we have enough to hold on to in that vise when we have to machine that hat off and things of that nature. So again, I'm going to actually swap out from top dead center. So if I go back to setup here, we're actually going to use bottom back left corner as if I had a stop and I was on a set of just step jaws. This makes my setup 10 times easier to always use the same point time and time again. So with that, we can go ahead and hit OK. And now we can start by either facing off our part or roughing out. Personally, I'm not going to face this part because this is such a small area. I'm going to save a tool change because I have a trick when we actually machine this flat later. We're going to do it all in one shot. So I am a big fan of going 3D right out the start. So let's go 3D adaptive clearing. Let's go ahead and define our tool. I'm going to go with a 1/2 inch cutter here. So let's go through our library. We are going to make some modifications to this 1/2 inch tool in a second, but you guys are going to see some neat things here. And because this part is aluminum, we're going to go aluminum roughing. Moving a little further on here, I'm actually not going to define anything. And for a lot of you, you're going to notice that this rest machining, you've kind of lost stock, right? The reason why you lost stock is because of rest machining. So when rest machining is toggled on, your stock contours has disappeared. So for most of you, you're used to seeing that yellow box around your part. That's no longer the case because in rest machining, you can actually tell it from setup stock, which is another way to define this, or from previous operations. Geometry-wise, we don't actually need a boundary because we're not doing a pocket or a specific area. As always, we're going to work from stock top down to our model bottom. And then if you didn't catch my little tip trick the other day, I actually created an expression, and that expression takes the vertical stock to leave and times it by a negative. So this was something that's really neat in one of my other videos. So if we're leaving 20 at the bottom, it's automatically taking away that 20 in my depth. Again, my passes tab, we do have the optimal load set to 1/8 inch. That's more than okay. Maximum step down, fine step down, and a minimum step down here. So let's go ahead and hit OK and see what we get. In most cases, I like to just send this tool path without actually ever having to adjust anything because a lot of it's driven from my tool data or just habits. So one thing I did forget though is because if I am to simulate this actual path right now, with my stock, and we're going to stop if there's a collision. You're going to notice in my timeline right away, we do have some red areas. And that red area is going to be triggered by hitting my tool holder against my part. So how can we remedy that? Well, as you can see, we could always go to a longer tool, but let's let Fusion actually do the thinking on that. So we're going to say shaft and holder. I'm not going to do a pull away, but I'm going to do a detect tool length automatically. So again, we've now reran that. It's self-generated. We get a warning message, and that warning message is telling us that we need to be between 1.1 to 1.7 inches of stick out. So half-inch end mill, almost 4 times diameter stick out. We're going to be more than okay. So I'm actually going to regenerate this one more time to get rid of that error. And again, we can now simulate this with machine. We're going to go ahead and hit play. I'm going to let this run through very, very quickly. Guys, I have my accuracy turned way down on a part like this. And I also have looping turned on. So let's go ahead and right click and turn off loop so we can get all the way to the end and pause and just give a quick glance. So just like that, we have roughed out basically everything and anything from that view with just one toolpath. And this is why I love that toolpath. So from here, we're going to go ahead and I'm actually going to kick on transparent just for future purposes. But let's go ahead and do our now finishing. Me, I'm a big fan of finishing the floors before the walls. So again, this is where my 3D toolpaths come to rescue. You can do either a flat or a horizontal. I don't think there's a right or wrong answer here. I come from the old school way before flat was a toolpath. I really like horizontal. It's always worked very well for me. The only thing that I like to fix about this toolpath is because I don't want to touch the walls, we're going to go ahead and tell it to leave, and I'm going to go 0.25. So we roughed to 20. I'm going to give it an extra 5 just to make sure we never actually touch the walls. And then we're going to actually go to 0 on our axial. So what's going to happen now is we're going to stay away to make sure that we never get into weird corners and do that little burnt move that causes surface defects. But we are going to finish the surface as much as possible. Again, because of the way Fusion 360 works, it's great because you can actually simulate this. We can run it all the way down. And as you're going to see is we're going to get that double kind of step in here now because we stayed 25 away from our walls. Plain and simple. So now we can finish up our walls. Again, personal opinion on how you all are going to do this. Now, if I have to hold some very tight tolerancing on a part, I may actually come in with 2D toolpaths and do a 2D contour, allowing me to use things like wear compensation. Now, if this part was plus or minus 5, I would, again, go 3D. And the reason for that is because 3D contour, you could actually kind of use it like 2D by a couple of settings here. So we're going to go to slope to start with. And we're going to tell it we want to go from like 89.9 to 90 degrees. I don't have any chamfers here. I don't have any slopes. I don't have any organic shapes. Basically, what we're telling it is stay vertical. Don't do anything that's not vertical. Just do the vertical stuff. So we are going to also have to tell it tool outside of boundary. And a few other settings that we are going to actually have the ability to adjust if you guys need. Maximum step down. Again, I may push this out to a 1/2 inch. We do want to order, or we do want to find all the flat areas. So let's make sure that's checked and let's hit OK and see what we get. So as you can see, we are making our 1/2 inch step downs. Given when we designed this part, it's actually 1.5 inches tall. And then we did come back with one final pass. So we should have just had 3 1/2 inch passes, but we added an additional pass to come in and clean up that step in there to make everything nice and pretty. So a few things that most of you may want to adjust. You always want to go past the bottom of the part. Again, we can adjust that in our heights tab. I'm going to go minus 0.02 past the bottom. Another thing I don't want to do is helical bore down. It's wasted cycle time. So if I go to my linking tab and I come down here to where it says helix, we're just going to plunge. And simply enough, we are now plunging down, going around, and then rinse and repeat over and over until we finish that profile. So again, super valuable, as you guys could see, to be able to go in and use 3D to recognize vertical surfaces. Now, I may not want to do this bore. We've kind of talked about this. I want to go in and I actually want to make this bore precise, right? So what I'm going to do is I'm going to go back to that toolpath. Again, I'm going to go down to where it says avoid, and we are going to avoid that surface. So again, we simply add in what we don't want to do, and just like that, it's avoiding. But I did cause some conflict here because we now are avoiding this back wall because it doesn't want that tool to overlap that edge. This is very common. It happens to the best of us. Sometimes we can't get away with what we want to do, so we either have to add on features to Fusion, so we could do toolpath trimming, guys. This would be a great situation for it. Or we can actually do another trick that I've always found very handy, is what if we just patch that surface real quick? So let's jump back to design. I'm going to go to surface. We're going to add a patch in here. We're going to hit OK. We're going to go back to manufacture, and we're going to go to that contour toolpath. Now, in geometry, you have what's called model. I'm going to turn this on, and if I pick that patch, what's happening here is we actually are taking that face or that patch that we made and the setup model, which is the L bracket, and we're including both of those into our toolpath. So as you can see, we're now actually going into that hole anymore because that surface is in the way and interfering for it to happen. Now, we expand our design tree out a little bit. Again, this is me being me. I like to get the patch out of the way so we no longer have to stare with it and go crazy. But we're now going to go in and we're going to just bore this out. This is where, again, if we were to do 2D contour or 2D bore, I like 2D bore because it's going to helix in. But we're going to turn on where so that we can adjust that. And we're going to pick our face. So just like that, we're now helical boring down into our part. So let's now do some chamfering and some spot drilling. So one neat thing with Fusion is this 2D chamfer is designed if you have square edges. And by square edges, I mean non-modeled chamfers, right? So we're going to say 2D chamfer. I'm going to go out. I'm going to pick my tool. My shop crib, I do have this lovely 3/8 90 degree. I am going to manually have to stick this out because as you guys can see, I don't have shaft and holder here. So let's go ahead and edit our tool stick out length. And I'm going to go ahead and stick that out to not 3 inches. That's way bigger than my tool. Good thing Fusion knows better than I do some days. So let's go ahead and accept that tool. We're going to select it now. I'm going to go ahead and pick my edges that I want to do. So I'm going to go ahead and do that bore, and then I'm going to do this outside edge. And then lastly, we're going to do this upper edge all the way around the outside. So as you can see, Fusion does automatically go in and avoid the vertical walls. And this is, again, neat thing with some of these toolpaths, the ability to think ahead of you. So we actually have what's called a chamfer clearance, which means stay away from walls. Don't avoid these certain areas so that we don't cause a collision, as well as we can offset the tip. And then what I failed to do is add in, my 5 thou edge break or my deburring cycle. So again, I'll go ahead and hit OK, and we have that wrapped up. We're going to go back now. We're going to do a drilling cycle with that same spot drill. I'm going to go ahead and swap from my finishing to my drilling speeds and feeds. I'm going to pick my actual profile. We did luck out with 2 of these. And as you currently see, and this is because of the way the actual setup is inside of Fusion's Heights tab, whole top to whole bottom. I don't want to go to whole bottom. I want to go to a chamfer width, and this is something really, really cool here, is if I say my chamfer width on those holes is 15 thou, if I type in 0.015, you're going to notice this jumped all the way back to the top of my hole, but now it's actually going to spot that with a 15 thou chamfer around the outside of that hole. So again, this is a neat way, super fast to be able to get your spot drilling done and actually have it avoid areas of the model and not plunge to the bottom and cause all kinds of problems. So let's go back and do some more drilling. So I'm going to go ahead and inspect this because I did forget what we drilled this at or what we designed this at, 138. I do also believe this is a 3.5mm. So as you guys see, I went ahead and threw on those secondary units. So we go back to drilling, 138. So I'm going just to the default library. I like to organize by diameter so I can quickly scroll down and find that size. So we do have a 138. That's actually a tap. So let's change our filters here. So we're going to say drill. Now we're going to look for either a 138 or what is the closest thing to a 138. So I either have 136, which will probably drill a little oversized, always happens, or a 140. In this case, again, plus or minus 5 on this part, 136 is what I'm going to go with. If I wanted to go get a metric drill bit, guys, feel free to go do that. But same thing as when we did our spot drilling. We pick our first hole. We're going to say select same size diameter. And then in this case, in my heights tab, I'm actually going to drill tip through bottom. So let's get zoomed in here so you can see this. Drill tip through bottom. And with that, we're going to give it a breakthrough. I like to use 20. And just like that, we're now 20 thou broke through the bottom of our part, giving that nice and easy cleanup on the backside. So If you wanted to do a different drilling cycle, for most of you out there, is we can actually swap that out. So we could go to cycles and we can change that. In this case, that's such a, barely 2 times deep. We should have no problem drilling this without having to pack or retract or deep hole drill. So now we're going to run this through the simulation real quick and just verify everything. So what I'm going to do is I'm actually going to take transparent off. As you can see, my continuous rest machining has walked me all the way down here to the end. So let's exit, grab our entire setup, go back to simulate, and let's hit play. Again, this is going to run relatively quick. We're noticing that there's no collisions. That's the key element first and foremost. Don't smash your machine, right? Second thing would be is how close are we or how accurate are we to everything we're doing? Now, what you notice here is I have some very funky things going on with my graphics. The reason for that is because I turned my accuracy down to very quickly simulate this for collisions. Now, if I turn it back up a little bit here and we re-simulate, what you're noticing is a much cleaner profile. I am also getting some island problems, and I know why that is, and I'll show you why. But at the end of the day, what we're really looking for is anything that is going to be a dangerous situation on this machine. I can turn my part off, and as you can see by turning off my part also, it cleans up even more. The comparison tool is one of my favorite things because it's going to show you green, red, and blue. Red is bad, green is good, blue is still waiting to be done, right? So let's go ahead and adjust this so we can go a little deeper with our roughing cycle. And again, when you guys create your own system, I'm going to turn my model back on. But when you set your offsets for your depth, again, you guys, you always want to account for that actual stock to leave. So what I may do here is I may now edit this expression. So I'm taking that times -1 to make it a negative number. So I'm going to throw this up in brackets. You guys don't have to do this by any means, but I'm going to take this and then I'm going to subtract another 0.02 from it. So as you're seeing, I do have to add in the words IN for inch because if not, it's thinking that's millimeters. So let's go ahead and add in IN. And now you're seeing I'm getting a total of -40 on that actual compensation. You can save that as a default, guys. It is asking me to regenerate everything, so let's go ahead and regenerate this. So now that that's regenerated, we go ahead and run our simulation one more time, and everything is checking out as is. I like it. Everything's nice and clean. We do have this big ugly hat, so we can go ahead and machine that hat off next. So what I'm going to do is I'm now going to create a brand new setup. I'm going to set my Z-axis. My Z-axis is now going to go up. And again, just to make my life easy, and it's up to you guys how you do this, but if I had a stop in my machine, and I know where that stop is I'm going to use this top back corner. So we're actually going to say model box point. I'm going to click that back top left corner, and this is a little bug that happens in Fusion. Notice how I clicked it and nothing happened. Well, if I move to a different location, then to that location, I have a tendency to make that actually work. But now, again, you're seeing that it's still not working. And the reason why it's not working is because that is actually the origin of my part, and it doesn't know what to do. So we're going to swap from model box point to our actual model origin. As you can see, it's now jumped to that back left corner, which is where this part was drawn and designed from. I do like my X or my Y and my Z direction. This is working out amazing for me. But the key element here is if you go to stock and you have a couple of options, so you have from preceding setup. So this is the one that I always like to use in my second op. You also have from solid, you have the fixed size box like we did in the first op. But the second part of this that's going to be very beneficial is the continuous rest machining, which is going to demonstrate that hat as we add our toolpaths. So let's go ahead now and let's face off our part. I am going to grab a big 2-inch cutter for this. Not really going to worry about speeds and feeds from here, guys, just because you guys are all going to customize this to what you do. It's, again, this idea of this video is to get you much more content on how to make these paths than what to do. So again, we have our stock contours coming in. I have my heights tab. We are going from stock top to model top. Again, facing cycle. We don't want to go past the top of our model. I am going to turn on multiple depths. And the reason for that is because I would like to make this in nice step downs and not damage everything and anything. So I go ahead and hit OK. As you can see, we're now making 2 passes down and back. We are retracting every time, which I'm going to clean that up. I don't like it. But the idea is that we are cleaning up this part time and time again. So let's go ahead and turn on our stock. So we turned on our stock, and as you can see, the more and more we machine this, with the exception of those 2 grooves, my stock model is updating throughout the process. Again, super neat thing that if you go to these different tool paths, and I click through these with my stock turned on, it's going to automatically update and show you kind of what you're doing. So just like our facing cycle, we've now knocked everything off. Given I've actually set this reference point at the machine, and I'm probably doing more than one of these, maybe we're doing 5 or 6 of them, let's go ahead and throw a chamfer cycle on this just because we're looking at this view, and it's very easy to clean up. So I'm going to go back to 2D, and I could go to chamfer, and I could recreate this whole process. Or I can cheat, and I can actually take, when we did our 2D chamfer before, right-click copy, go down to my setup, right-click paste, and then I'm going to go in and edit this, and what I'm going to edit is the actual contours selected. So we're going to unselect those, we're going to reselect them, and now I'm going to go ahead and hit OK. And just like that, we're going in and we're chamfering everything on the backside because we're looking at the part from this view. Again, this makes my life super easy to make sure we have some clean parts that aren't going to cause all kinds of problems. So now we're going to jump into our third operation. So not third operation, but our third setup. So again, we're just going to rinse and repeat this, guys. We're going to go ahead and say new setup. Again, I'm going to say what I want for my Z. I'm going to put Z up this way. I am actually going to reutilize that model origin point down there. So we're going to go ahead and swap this out to model origin. If I wanted to use a selected point, guys, you could do a selected point too. I just like kind of holding it in this position, putting it right on top of a set of parallels or a step jaw. Super easy to always keep my stop on the left side as well. My stock, again, is from proceeding, continuous rest machining, and we're going to go ahead and hit OK. So we're now looking at it from the top view. All we need to do is mill out these couple of little slots. So I'm actually going to do these with a 2D contour, and the reason for this might shock most of you in a minute, but we're going to go in and we're going to actually grab a 1/8 inch end mill, not an 1/8 inch spot. So again, let's go ahead and filter to a flat end mill, 1/8 inch flat end mill. We'll go aluminum slotting for the sake of doing speeds and feeds, and you guys don't hassle me in the comment area. And now we're going to define our geometry. This is where I'm actually going to pick the lower chain of each one of these slots. I'm going to take one step further. We're going to go to our heights tab. Again, we always want to break through the bottom so that, you know, if there is a burr or we have to flip and do a hat off the backside, there's no issues. And then we're going to walk this through a few other things. So this is the part that confuses, I think, a lot of people. So we're going to first off hit OK. And what you're going to notice is we're plunging down in there and we're just hammering around this part. Could I pre-drill these? Yes, guys, feel free to pre-drill them. I'm not going to pre-drill them. I'm going to ramp into my part at an angle and just machine those out very nice and simple. So again, I'm going to go back to 2D contour, and I'm going to take this, and I'm actually going to say is I don't want to do a lead in and a lead out. I would like to do a ramp, and then you could set your angle of ramp to whatever that may be. So let's go ahead and hit OK. And as you're going to notice, it's okay. Everybody makes mistakes, right? We're starting way too high with this ramp. So we're going to go ahead and adjust this. The good news is we're ramping all the way down to our bottom contour, and it looks like in X and Y we're good. The Z axis is completely wrong. So we go back to our heights tab, and now we're going to just say, I want to select the top face to work with. So now I'm selecting that top face, and as you're seeing, when I hit OK, we're now ramping much closer to that face, saving us a ton of cycle time, and to keep that nice and easy on that tool and keep everything nice and safe. Another thing is because the way our retracts are all set, we're still coming up very high to jump across. That's more than okay. To just, again, I like it as a safety caution to avoid so that we don't damage anything when we're machining or smash into our tools. So again, we could go ahead and do our chamfer move all over again. We're going to go ahead and copy. I'm going to go ahead and paste that down below. And we're going to go ahead and double click. Again, we're going to redefine all of our chains. So I'm going to delete all of them. Go ahead and pick my edges that I want. And again, we're going to go ahead and hit OK. So just like that, we're now chamfering that side of the part as well. We're getting those actual slots all machined out. And you guys have that kind of ready to machine. So let's just run a simulation on this last part to make sure there's no big problems. And just like that, we have a huge problem. As you can see, our tool is way too close to our actual upright here. So coming down and machining this way in particular is not going to be a good case. Now, I'm not going to show you guys how to make an extension to your tool or an adapter to step it down to a smaller shank to get it here. What I'm actually going to do is take probably one of the best machinist approaches, which is either laziness or proficiency, and I'm just going to flip my part over. So let's go ahead and adjust that real quick. So we're now going to say, I don't want Z down. I want Z up. I'm going to go off that back left corner. So again, we're going to say selected point. I have my stop back there. There's no reason for you guys to work harder than you have to. And now I will have to readjust what we defined here. So what I really want is, in this case, I can switch this back to stock top because it actually will matter, and you guys will see this. But we're going to leave it at stock top, and then our selected contours back here in my contour selection, we need to put those at the bottom in the opposite direction. So we went ahead and misclicked. I'm going to click that a second time. I'm going to hit cancel here. We're actually going to do it here in the menu where I can delete that chain because I picked the wrong edge way too deep in my part. So now we have our lower two chains. Again, we're going to hit OK. My ramp is a little too high because of that stock height. So we're going to go ahead and stock top to model top. And now we're starting up here at the model top and working our way in. Again, we're going to clean up our chamfer cycle. Also, unselect everything tends to be the fastest way. Repick all those upper edges and hit OK. And just like that, we have now reapproached this from a different angle. And if we are to simulate this, knock on wood, we shouldn't get any crashes. And we went way too fast to really even know what happened there. Speed this up just a little bit. There's my ramping cycle in, cleaning out that first pocket, ramping cycle in again, cleaning out that second pocket, chamfer tool running around all those edges. And now we have a nice deburred part that nobody's going to cut their fingers on. Hey guys, I hope you like this Milling Monday video. So the only thing I'm going to ask of you guys at the end of this video is if you guys like content like this and you're really enjoying the stuff that I'm making, is all I ask from you is that buy your licenses through jitcadcam, where I, the owner of the company and the only employee at this time, is how I tend to pursue my future with doing this. So with that being said, is use the link down below. Feel free to buy from us directly. As well, you can move your licenses over to us as well and show us your support. As always, have a great rest of your day, guys. Get the day done.